everybody, welcome to our first Fillamentum webinar where we can have a look at the tricky nylons, their 3D printing properties, their final properties, their constitution, etc. I'm here with Martin, who is our expert for 3D printing. He is able to print every material.
And this is Martina, our polymer specialist. So let's take a look what our webinar will be about. We will be talking about the nylon and its composites. We will also talk about the principles of modeling, 3D printing, troubleshooting. We also prepare a few case studies for you. And at the end, we have a little surprise for you, so stay with us.
So first of all, we will have a look at the nylons and its composites. So what is a nylon? It is a polymer that is consisted from polyamide 12, which has the structure shown in the picture. You can see the monomer and its functional amide group, which predetermines the final properties of the whole polymer. Because this monomer is long and rigid, it creates very rigid polymer chains, which leads to high crystallinity of the polymer, and therefore we get very stable structure of polyamide, and it leads to very resistant material to chemicals, to wear, and to temperature. Because when we have a look on this picture, there you can see regions of high crystallinity and regions of amorphous structure. And the ratio of these two regions predetermines the final properties. And we know that if it is highly crystalline, there is a lot of regions with very stacked polymers chains together. It is highly organized structure, very regular, and when, for example, a molecule of solvent comes to this structure, it is really hard to attack it in the middle of these chains. So therefore it is very resistant to it. When you apply some wear, it is the same. And what is a composite of the nylon? It is a polymer that is filled with some filler. For example, for modifying the hardness or some other mechanical properties. It can be to achieve the conductivity of the polymer, to have nice surface, but mostly for a better price. Therefore, there are common fillers like chalk, kaolin, talc. We also use a lot of fibers like glass fiber, carbon fiber, natural fiber, or other nanofillers, etc. In our portfolio, we can find 3 types of nylons. Nylon FX256 is clear polyamide 12. If we fill it with we have filled it with milled carbon fibers to achieve nylon CF15 carbon, and with milled aramid fibers to achieve nylon AF80 aramid. Then we get the materials that have higher pressure resistance, higher wear resistance, nice surface of the printed object, and higher stability of processing by 3D printing. If we have a closer look on the relation between chemical structure and 3D printing, we need to understand the semi-crystalline structure and how it influences the processing. It is really important to understand the semi-crystalline regions are very well stacked by the intermolecular interactions, and it's needed to be melted properly. We need to give it a lot of heat to melt it, to loosen the polymer chains, and to minimize the shape of the shape memory of the polymer. And if we can loosen the chains well, we can create the new shape more easily. And it also relates to cooling down. When we have these crystalline structures, it needs to cool down slowly because it takes some time to organize very well. Or otherwise, if we cool it very rapidly, it creates amorphous, irregular structure, and the polymer chains are just connected like spaghetti, for example. And if we have regular crystalline structure, it won't work so hard, it won't be brittle, and therefore we need to set good temperature of the pad, of ambient environment, and good fan speed. In case of composites, there are some fillers that help us with the lowering of the crystallinity. The polymer chains don't have so much space to organize the structure because of the fillers in the structure, and therefore it is easier to process it. But we must take care of the moisture because it helps with the absorption into the structure. And what is important that specifically this amide functional structure group must be in very dry filament because if we loosen the chains, the structure is not connected, then we can achieve the degradation of the polymers by the molecule of water, because the chains are more available for the molecules of water, and it creates cutting of the polymer chains irregularly, randomly, and then we can get some short, some long chains, and it creates very unstable processing. Now we have a look on some 3D printing and modeling by Martina.
So I have prepared a few basic tips for 3D modeling. If you are printing with nylon, because it's some kind of specific. So if you are modeling a part, avoid sharp corners in the design if it allows, because sharp corners usually increase the internal forces when the material cools down. And as Martina mentioned, the nylons or also polyamides need to cool down in stable environment. So that's quite important. Also, overhangs in the model less than 50 degrees, because if you exceed this degrees, the material curl up to the nozzle and warts a little bit, so sticking with 50 degrees is quite good. And if you have small features or have several small parts printing, there is a little bit of requirement to 4 times nozzle size, because if the part is too small, the material don't have enough time to cool and result in failed prints or blobs. So 4 times nozzle size is something you should mention in the design. Okay, there's I would like to talk about some basic settings for 3D printing. So the temperature of our printing temperature of our nylons is 240 to 260 degrees, 90 to 110 degrees of Celsius on the hotbed. The printing speed should be around 30 to 50 millimeters per second. But definitely I would recommend to use 20-25 millimeters for the first layer to ensure the adhesion, good adhesion to the build plate. Part cooling fan 0 to 20 millimeters. That's we always repeat, because polyamides need to cool down in proper way to ensure good layer adhesion and so on. And for the adhesion, PVA glue or Mejigu PA. Also, we have a few tips for when printing with nylons. A large enough brim is quite good, 10 to 20 millimeters depending on the object. If you have enclosure or heated chamber, that's definitely great. You have a stable environment and you have less troubles with warping when the nylon is printed in the enclosure and the stable environment. Part cooling fan off if you are trying to print the strongest part as you can, so definitely no cooling fan. The layer bondage is perfect and you have the strongest part what you can achieve. What is really necessary with nylons, also with polyamide based filaments, is to keep them in airtight bags. Proper storage is really important because nylons are generally quite hygroscopic, so they absorb lots of moisture from the air. So also from our experience, it's better to use glass or mirror surfaces for the printing than PEI because the PEI doesn't work so well for us. And if you are printing with nylon and don't have an enclosure or a heated chamber, avoid any open windows. Airflux can lead into warping. So the stable environment during the print is also crucial. Okay, so we have prepared two pictures of two different build plates, a little bit of comparison between them. On the left side we have a PEI and on the right side we have a glass or mirror. The both printed objects was printed with same settings and also with same bed preparation. So as you can clearly see, there is a big difference between those. On the right side with PI, the warping effect is more visible. So we recommend glass for the printing nylons. Okay, now we take a look into troubleshooting. We have prepared three common issues you can face during printing nylons. The first one is definitely warping. It can be caused by several reasons, like too low temperature on the hotbed, also on hot end, also too much cooling of the part. Also warping could be connected with humidity in the filament. So if you have a wet filament, it increases the warping effect of the nylon, and the adhesion isn't so good as with the dry filament. Also, the common problem with nylons are stringing. If you are printing small parts with small features or several small parts, and you are seeing the spider webs between the parts or features, usually it's connected to humidity again. As we mentioned before, keeping the filament in the proper way in the airtight bags with desiccants is really important. Also, in less cases, the stringing could be caused by too high temperature of the nozzle because you have melted too much and the filament is leaking too much. And the third one is brittleness. That is mostly caused by too much airflow from the part cooling fan. When the speed of the part cooling fan is too high, the layer don't have enough time to cool down properly, and the material is brittle, so you can easily separate the layers by hand. so the printed part is not so strong as you want. So that's also important. Okay, Martina also described a few things about composites, and also printing with composites is some specific rules. We always recommend to use wear-resistant nozzles. Dexter Ruby, Olson Ruby, hardened steel, etc. I want to mention just one thing. If you are using hardened steel or stainless steel nozzles, please bear in mind that those two types of materials have different thermal conductivity, so usually you have to bump up the temperature a little bit by 5 to 10 degrees because of the thermal conductivity. Also, what is interesting about composites and printing with them, that they have a better adhesion than pure nylons because of the fillers in them. As Martina mentioned, the particles disrupt the space of the polymer chain, so they don't have enough space to crystalline in space. So that's why they have a better adhesion. And also, this is really important. The composite filaments are usually for parts which are loaded in static way, like for hardness, pressure resistance, wear resistance, and so on. Because the carbon fibers or iron fibers are usually quite short, so they don't have enough improvement in dynamic weight load. Okay, also we have prepared some case studies for you to show the wide use of this material in industry. The first one is from Institute of Geology of Czech Academy of Science, and the use of nylon IF80 aramid. The object is part of a measurement device of seismic waves on rock walls in high pressure chamber, and the purpose was to product mechanical sensors, holders, sensor bodies, and motors for high pressure chamber. Because the problem was the high price of the parts produced on milling machine, and also the long lead times. So the solution was the 3D printing, which speeds up the production and highly reduces the costs. Furthermore, the printed object and the design can be easily and quickly modified for current needs. So if you have a different holder, different motor or something like that, it can be quickly done, and so you just print it. So you save a lot of time and also a lot of money. And second one, it's up to Martina.
The other case study is made by the company Stepanek 3D, and they are here for the customers that have specific needs, and this company is able to deliver it very fast and according to the specific needs. The object was planetary external gear. It was originally from aluminium wheel, and it was designed by this company, and with the material nylon CF15 carbon, and with optimal infill percentage, they achieved huge saves with the weight, and also especially cost savings and shorter delivery time. But it also maintains its functional strength and rigidity, so that was the perfect material for this object. And now we have a surprise for you, as we have mentioned on the beginning of this webinar.
Okay, so after long development, we have prepared for you the build plate for your hot bed. It's called LockPAd. It's specially designed for polyamides. It's in 30 to 38 centimeters rectangular shape, so it can be cut into any shape you need according to your printer. If you have a rounded, like a trilateral, if you have a rectangular, so no problem. It's made for polyamides, but it has also a great adhesion of a wide range of polymers. When you are printing with polyamides, so no need of adhesives for it, and with ease of removal. And so it will be available at our e-shop. So check it. It will be in a limited quantity. So don't waste your time and take a look. And if you are struggling with printing nylons, so definitely a great addition to your printer.
So thank you for your attention. Thank you for joining us today on our first webinar. We look forward to see you at next webinar that will have a look on our flexible materials, and we will also share new material with composition based on feedback. And I think you can look forward to it too. In the meanwhile, if you have some troubles with your 3D printing, don't hesitate to contact us on our help desk. We will surely help you. If you also have some problems with material choice, don't hesitate to use our filter, use our product documentation, take a look on our website, there's everything written. And if you're not sure about it, don't hesitate to contact us again on our help desk.
Yeah, and also if you have any suggestions for us, what you would like to see and what we haven't mentioned, so just write us.
Thank you.
Thank you. Bye.
Bye.